All right, so today we're diving deep into the tech that is, well, pretty much changing everything. Large language models, or LLMs. You know, it's the engine humming away inside all those AI tools we're using every single day. So let's pull back the curtain and see what's actually making it tick.
I mean, you've definitely used something like ChatGPT, right? Maybe you asked it to write an email for you, or hey, even help with some homework. But have you ever just stopped and wondered, what is actually going on inside that black box? You know, how does a machine, a piece of code, learn to talk in a way that feels so human?
Okay, so here's how we're going to tackle this. Think of an LLM like a big onion. We're going to peel it back layer by layer. First, we'll look at its brain, the core architecture. Then we'll see how it learns, where it gets all its knowledge from. And finally, we'll dig into the really cool math that actually makes the whole thing work. So let's get to that first layer, the brain of the whole operation. This is an architecture that just exploded onto the scene back in 2017. And I mean, it changed everything. It's called the transformer. And it's basically the blueprint for almost every single modern language model we have today.
And this was the title of the research paper from Google that introduced the transformer. Attention is all you need. It sounds kind of poetic, right? But it's not just some catchy title. It is the central, absolute, game-changing idea. What the researchers found was that this one single mechanism, what they called attention, was so powerful it just blew every other approach out of the water.
So what is this attention thing, really? Well, let's break it down. Simply put, it's the model's ability to figure out which words in a sentence are the most important for getting the meaning, even if those words are super far apart. You know, think about how you read. Your eyes don't give every single word the same weight, right? You instinctively zero in on the key stuff. Attention basically gives AI that same kind of intuition. Okay, let's make this super concrete. Take this sentence. Masha gave an apple to Sasha. She was hungry. Now, the question is, who was hungry? For a machine to get this right, it has to figure out what the word she is pointing to. Is it Masha or Sasha? The attention mechanism is what does this. It looks at all the words, weighs the relationships, and goes, aha, she is most likely connected to Masha. And that ability to untangle ambiguity is exactly what makes attention so incredibly powerful. So, okay, we've got the transformer brain. Awesome. But a brain is pretty useless if it doesn't know anything, right? So the next layer of our onion is the fuel. Where on earth does an LLM get all its information? The answer is pretty simple, actually. It reads the internet, and not just a little bit of it, a massive, unbelievable amount. And just to give you a sense of scale, look at this number. 175 billion. That's the number of parameters in GPT-3, which was one of the models that really kicked off this whole AI explosion we're in now. So what's a parameter? You can think of them like tiny little knobs and dials inside the model's brain, or maybe like synapses. It's this absolutely colossal number of them that lets the model soak up and make sense of all that data from the internet. But here's the thing. The learning doesn't just happen all at once. It's actually a two-step dance. First up is pre-training. This is where the model just learns the basic rules of language. And then comes step two, the really crucial part, fine-tuning. That's where we teach it how to be a helpful and safe assistant for people like you and me. So in that first step, pre-training, the model has one super simple job: predict the next word in a sentence. That's it. That's literally the entire game. But when you make it do this billions and billions and billions of times on text from all over the internet, something amazing starts to happen. It's not just memorizing stuff. It actually starts to absorb grammar, learn facts, and even pick up on patterns of reasoning, all by itself. Now, after that pre-training, the model is like this brilliant, massive library that knows almost everything. But it's completely disorganized. It's not really a useful assistant yet. That's where fine-tuning comes in, using a process called reinforcement learning from human feedback. A mouthful, I know, so we just call it RLHF. Real humans basically become its teachers. They look at the model's answers and give them a thumbs up or a thumbs down. Over time, all that feedback shapes the model into something that gives responses that are actually helpful, safe, and, aligned with what a person would want. Okay, time to peel back another layer of the onion. So we know the model learns from feedback, but how does it actually learn? Like, what's the mechanism that lets it adjust itself and get better? To get that, we have to look at the engine under the hood. And, yep, that means we're talking about the math. But don't worry, it's actually a really cool and intuitive idea. The whole thing revolves around a concept called a loss function. It's just a fancy name for a score that measures how wrong the model is. So if the model predicts the next word should be house, but the correct word was mouse, the loss function spits out a high number. It's basically an error score. The bigger the screw-up, the higher the score. So the entire goal of the training process is to get that error score as low as humanly, or I guess as low as machinely possible. The process for doing this has a cool name, gradient descent. And the best way to visualize it is to imagine you're a hiker lost in a super foggy valley. You can't see the bottom, but you can feel which way is downhill, right? So what do? You take a step in the steepest downward direction you can feel. That's exactly what the model does, just in a mind-bogglingly huge, billion-dimensional landscape of numbers. It's always trying to take a step downhill to lower its error. So when training first starts, the model is basically clueless. Its predictions are just random guesses. So as you can imagine, its error score is sky high. Our hiker is standing way up at the top of a peak, with a long way to go down. And so using that error score as its guide, the model makes a teeny tiny adjustment to all of its 175 billion parameters. It just nudges all those little knobs a bit in the direction that it thinks will lower the error. It takes one small step down into the valley. And then it does this again. And again, millions and millions and millions of times. And with every single one of those tiny steps, the error gets a little bit smaller. The hiker gets a little bit closer to the bottom of the valley. This simple loop, predict, check the error, and then adjust, this isn't just for language models. This is the fundamental heartbeat of how almost all of modern AI learns. All right, we've made it to the final layer of our onion. We've seen the transformer brain, we've seen how it's fueled by the internet, and we've peeked at the mathematical engine that drives it all. So now, let's look to the horizon. Where's all this headed? What's the next big thing for AI? The new frontier, it seems, is all about one word: reasoning. For a long time, the name of the game was just making models bigger and bigger. But now, the focus is shifting to making them smarter. Instead of just spitting out an instant answer, researchers are teaching models to create an internal chain of thought first, to actually work through a problem step by step before giving the final answer. Basically, they're learning to think before they talk. And the results of this, they are absolutely staggering. I mean, just look at the difference on this table. Simply by asking a model to think step by step, its accuracy on really tough things like math problems and logic puzzles just skyrockets. It's a huge leap. This proves that just giving the model a little more time and a process to think can dramatically improve the quality of what it produces. So here we are. We've gone on this whole journey from the core transformer brain all the way to the absolute cutting edge of AI research. We started with a model that was just trying to do one simple thing: predict the next word. And we've ended up with models that are showing glimmers of being able to reason through really complex problems. Which leaves us with one last pretty big question to chew on. We definitely taught AI how to talk, but are we now finally teaching it how to think?